I'm Annapurna, working as an assistant professor in the Department of ECE at Institute of Aeronautical Engineering. Today we are going to study about digital voltmeters. What is the need of digital voltmeters? Why we choose digital voltmeters for measuring voltage? So till now we have discussed about DC voltmeters and AC voltmeters. In DC voltmeters, we can directly measure the reading with the help of PMMC meter. Whereas in AC voltmeter, we have a needle. With the help of that needle, we can measure the voltage. But if you use DC or AC voltmeters, there exists some sort of disturbances or there exists some reduction in its accuracy. So we go for digital voltmeters. In digital voltmeters, the speed is very high. The main advantage of digital voltmeters are speed is very high and accuracy is more compared to the normal voltmeters. We have different types of digital voltmeters. These digital voltmeters are designed to measure the quantities other than voltage. They can also be used to measure frequency and time period. That is, we have different types of digital voltmeters like direct measurement of voltage to frequency, or measurement of voltage to time. Finally, we can measure different types of parameters like voltage, frequency and time period. The main advantages of digital voltmeter, why we choose are accuracy is very high and high resolution. It has greater speed and low parallax error, reduced human error, compatibility with other digital equipment for further processing and recording. If you go for an AC voltmeter, there exists a needle. Due to this, we have to measure the reading. If you have a needle like this, pointer, while measuring the readings, the reader can get any problem. While measuring the reading, the reader has the problem. While measuring the readings in AC voltmeter, the reader having so many problems while measuring because due to its vision, he may get the reading here instead of getting the reading in another point. So that in AC voltmeters, we have certain error like parallax error. But in digital voltmeter, we have a meter that indicates the reading like 0.15 or 0.23 like that. So that there exists no parallax error. And another thing is high speed. These meters, whenever we apply the input to the given circuit, it produces the output without any delay. And for the given input signal, the voltmeter responds very quickly and produces the output. So very high speed, and it reduces the human error. So direct measurement of readings are existed, so that human error, there exists no possibility of human error, and it is more compatible to connect any other devices for further processing and for recording. So all these are advantages of digital voltmeters. The main advantage of digital voltmeter is high accuracy and resolution. So if you are applying certain input, we get the output without any delay. At the same time, the output we have obtained is more accurate because the output we have obtained has the reading which is equal to the theoretical value. The theoretical value is almost or exactly equal to that of the reading which we have obtained in the output section. So accuracy is very high. From this we can say that digital voltmeters having so many advantages. And we have different types of digital voltmeters, and each digital voltmeter is construction is different from the remaining digital voltmeters. So how can we distinguish one digital voltmeter from the another digital voltmeter is, we have these parameters: the number of digits, number of measurements, accuracy, and speed of reading. With the help of these four parameters, we can distinguish one digital voltmeter from the another digital voltmeter. All the digital voltmeters are different in their construction, as the number one voltmeter is used to identify, one voltmeter is used to measure the frequency, means another voltmeter is used to measure the voltage. Like that, there exist different parameters for the measurement, and at the same time the number of measurements we need to calculate, that is also different. So based upon number of digits we need to calculate, and number of parameters we need to find out how speed it is responding and how accuracy it produces. Based upon these four parameters, we can define digital voltmeters in different ways. We have three main digital voltmeters. One is voltage to time converter, another one is voltage to frequency converter, and third one is direct measurement of digital voltage. In voltage to time converter, we have one type of voltmeter that is called as ramp type of DVM. Whereas in voltage to frequency converter type, we have two types of digital voltmeter. One is called as integrating type of DVM, and another one is dual slope integrating type of DVM. These two digital voltmeters are helpful to convert voltage to frequency. And third one is direct measurement of voltage. So in the direct measurement of voltage, again we have two types of digital voltmeters. They are successive approximation type of DVM and staircase ramp type of digital voltmeter. Finally, we have five types of digital voltmeters. These five types of digital voltmeters are classified into three ways: voltage to time conversion type, voltage to frequency, and direct measurement of voltage. In voltage to time conversion, we have ramp type of DVM. Today we are going to study about this ramp type of digital voltmeter. This is the construction of ramp type of digital voltmeter. This ramp type of digital voltmeter is mainly used to convert voltage to time. So that in the construction, it consists of mainly two blocks. The first block represents voltage to time conversion, and the second block represents time measurement unit. And before going to discuss about the operation of this ramp type of digital voltmeter, we will see what are the main blocks present in this ramp type of DVM. The main blocks includes ranging and attenuator unit, ramp generator, sample rate multivibrator, digital display, counter, gate, oscillator, and main thing is input and ground comparator. These are the main blocks present in the ramp type of DVM. Coming to the comparator, we have two comparators here. One is input comparator and another one is ground comparator. What is meant by comparator? Comparator is mainly used to compare the given two input signals. We have two types of comparators here. One is input comparator and another one is ground comparator. Input comparator, the name itself indicates that it compares the input signal with our ramp signal. In this ramp type of DVM, we are applying one of the input is the negative going ramp signal. So, the negative going ramp signal is given as the one end of the input to the comparator, whereas another end of the comparator has the DC input voltage. So, input comparator will compare these two input signal. If the two input signal having same voltage levels, then comparator starts operation. Similarly, the second comparator is the ground comparator. In this ground comparator, it will compare the two signals. Those two signals are, one is the input ramp signal, and another one is the ground. Whenever our ramp signal is equal to the 0 volts, then ground comparator starts working. These two are two main blocks present in ramp type of DVM. And another one is ranging and attenuator block. As we know that attenuator is mainly used to attenuate the signal. That is, it is used to send the required amount of input signal, and unwanted signals will be attenuated with the help of attenuator. At the same time, the ranging unit is used to amplify or strengthen the input signal. At the same time, unwanted signals will be attenuated with the help of ranging and attenuator unit. And next thing is ramp generator. This is the main important parameter in ramp type of DVM. As the name itself indicates that ramp type DVM. In this, the input signal we are applying is the ramp signal. We have two types of ramp signal: positive going ramp signal and negative going ramp signal. In positive going ramp signal, the input signal is moving towards above the axis, whereas negative going ramp signal starts from positive axis and it moves towards the negative axis. This is called as negative going ramp signal. So we are applying the input as the negative going ramp signal. So that's why initially the input is positive. As long as time passes, the input signal moves towards the negative direction. So we are using negative ramp signal. And next parameter is the sample rate multivibrator. This sample rate multivibrator is used to generate the pulse signal whenever requires. And next one is oscillator. This oscillator generates pulses or clock signal. And counter. The main purpose of this counter is to count the number of clock pulses passing through the gate during the time interval. And digital display. This digital display is mainly used to display the output. And coming to the operation, initially we are applying the negative going ramp signal. Whenever we apply the negative going ramp signal, initially its voltage is positive, that is greater than 0 volts. We are applying the negative going ramp signal, so initially its voltage is positive. Whenever we apply the negative going ramp signal, then the negative going ramp signal is given as the one of the input to the comparator. And another input to the comparator is the DC input voltage. DC input voltage. While we are applying the input, we have to reset the counter. Whenever we reset the counter, whatever the count that is present before going to start the operation, we have to reset the counter. The counter is resetted to 0. After resetting the counter value to 0, we have to apply the input. The one of the input for this comparator is the DC input voltage, and another input for this comparator is the ramp signal. The ramp signal we are applying to the input comparator. If the input signal is equal to the ramp signal, then the input comparator gives the signal that open the gate. Whenever the gate opens, the oscillator will send the clock pulses. As long as the gate is opening, the oscillator sends the clock pulses. During this time interval, the negative going ramp signal, the negative going ramp signal moves towards the negative axis and it reaches to 0. Whenever it reaches to 0, the second comparator or ground comparator will start working. Now the ground comparator Here the negative going ramp signal is equal to 0 volts. Then the ground comparator gives the signal that stop the count. As the count is stopped, the gate will be closed and the clock pulses passing through the gate will be stopped. So during the time interval from start position to the stop position, whenever the gate is opened, how many number of clock pulses are passing through the gate, that will be counted by the counter, and that is displayed on the display unit. In this way, during the time interval, during the time interval delta t, whenever the gate is opening to the gate is closed, how many number of clock pulses are passing through the gate, that will be counted by the counter, and that is displayed on the display unit. This is called as ramp type of DVM. Here, this is the ramp signal. This is the ramp signal and this is a negative going ramp signal, and we are applying the ramp signal input to an input comparator. Once again, verify the operation. Here, before starting the operation of ramp type of DVM, we have to make the counter 0. By resetting with the help of sample rate multivibrator, we make the counter as 0. Now the counter has count 0, 0, 0, 0. Whenever the counter resets, we will start the operation. We have to apply the ramp input. Here the ramp input is the negative going ramp input. So initially the input signal for the ramp, initially the voltage for the ramp signal is positive, and whenever the positive ramp voltage is equal to our input signal voltage, then input comparator has sent the signals that open the gate. As the gate opens, the oscillator send the clock pulses through this gate, and as long as we are the oscillator passing the clock pulses through the gate, the ramp signal across the input section moves from positive axis to negative axis. Whenever it reaches to the 0 volts, whenever ramp signal reaches to the 0 volts, the ground comparator will start action and it sends the signal as stop the gate or stop sending the clock pulses. As the gate is closed, the oscillator stops to send the clock pulses. Now the time interval between start count to the stop count. Within this time interval, how many number of clock pulses are passing through the gate, that will be counted by the counter, and that is displayed on the display unit. In this section, this is the where input comparator sends the signal to start the clock pulses or to open the gate, and this is the point where ground comparator sends the signal as close the gate. During this time interval, how many number of clock pulses are passing through the gate, that will be counted by the counter. In this, the input signal we are applying is the voltage, whereas finally we measure the time, how much time that the linear ramp signal takes for a linear ramp voltage convert. So how much time it takes for a linear ramp voltage to rise from 0 volts to input voltage and again decreases from the level of input voltage to the 0 volts. This time interval is measured with an electronic time interval counter. In this ramp type of digital voltmeter, we are comparing the time, that is whenever the input signal starts and when the input signal is equal to our ramp signal, and what is the time it requires the input signal or the ramp signal voltage is equal to 0 volts, and the total time duration is measured with the help of counter. This is called as RAM type of digital voltmeter. In this RAM type of digital voltmeter, the time T1 represents the time required for the, here we have two types T1 and T2. Ti- Time T1 is the time required for the RAM signal. The voltage of the RAM signal is equal to the voltage of the DC input. Whereas time T2 is the time required for the RAM signal, where the voltage of the RAM signal should be equal to the voltage of the ground. Huh? Voltage of the ramp signal is equal to the 0 volts. Finally, we measure ramp voltage at the point T1 and ramp voltage at the point T2. And during this time interval delta T, how many number of clock pulses are passing through the gate, that is counted, and that count is displayed on the display unit. So the main advantage of ramp type of digital voltmeter is, here we are directly measuring the voltage to time conversion. The accuracy is more compared to the remaining type of digital voltmeters. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.